Hey everybody, Professor Khan here. So continuing with our trigonometry unit, I want to talk about a reference angle first. This is going to be a very important kind of vocabulary piece because reference angles are going to be used a whole lot. First of all, a reference angle is a positive angle. It is an acute angle, which means that it only measures between 0 and 90 degrees. It's not going to be 0, it's not going to be 90, but it is going to be anything in between there. A reference angle is basically an angle that will represent an angle of another measure, right? Sometimes it will be the same, and sometimes it won't be. A very important thing about where a reference angle is located and how it is built is that it will be using the terminal side of an angle on top of an XY axis. And it will be using the x-axis itself, whatever the closest one is, okay? Always the x-axis. That is a very, very important feature of reference angles. The reference angles are going to come in 4 different types. Let's look at number 1 over here. This is a quadrant 1 reference angle, right? We can see in blue the angle that is on top of the xy axis, and then we can see in red the reference angle that is located there. Right, in a quadrant 1 case, a reference angle and the angle itself, theta, are the same. If we move over to quadrant 2, where the angle itself, theta, will measure between 90 and 180 degrees, in quadrant 1, a angle theta will measure between 0 and 90 degrees. But if we move to quadrant 2, where the angles are measuring between 90 and 180. Again, the initial side always starts in the same place. And this time the terminal side will fall into quadrant 2, which indicates an angle that is between 90 and 180. Right? We can see a reference angle here based on the terminal side and based on the closest x-axis, which in this case is the negative side of the x-axis. This is creating a reference angle located right here, which I'm calling R angle. A reference angle in the second quadrant will be obtained by taking 180 minus the measure of the angle itself. Quadrant number 3 means that the terminal side swung past 90, past 180, and down before 270. Somewhere between 180 and 270 degrees is the third quadrant of the x-axis. So based on the terminal side being located right here, we can identify that as part of the reference angle, and then the closest x-axis, which again is the negative side. And this creates a reference angle located just underneath the x-axis over here. Again, I want to repeat that we are always using the x-axis to locate our reference angles. In order to obtain the measure of a reference angle, take your angle of theta, which again falls between 180 and 270, subtract out 180 degrees, and then you will get the size of this reference angle right here. Quadrant number 4 means that the terminal side went past 90, past 180, all past 270, ended up down here somewhere before 360 degrees. So let's look at this. We have a terminal side again over here in blue. The red is going to sit on top of that. And the red over here is the closest x-axis. That is the positive x-axis. So it looks like the angles are the same, except remember how this is measured. The angle went in a counterclockwise direction and ended up in the fourth quadrant. We are measuring the reference angle right in between these two rays, right? So right over there underneath the x-axis. Again, always positive, always acute, and always made with the x-axis and the terminal side. So in order to find the measure of this reference angle, we'll take 360 degrees minus our theta. Another thing that we did not cover in class yet until today was the quadrants and how they pertain to positive and negative values. If these angles are in a right triangle, that means they are always between 0 and 90 degrees. So inherently, every single trig function, sine, cosine, tangent, and its counterparts of cosecant, secant, cotangent are all positive if the angle is between 0 and 90. If the angle, though, is greater than that, between 90 and 180 degrees, this is a second quadrant angle where the sine function is positive and also its counterpart cosecant. In quadrant 3, the tangent function is going to be positive. And again, along with that, the cotangent function. This is a third quadrant angle that measures between 180 degrees and 270 degrees. If the angle is above 270 but less than 360, that is a fourth quadrant angle where the cosine function and secant functions are positive. So we have this ASTC, which stands for all sine, tangent, and cosine. And we can remember this with a mnemonic called all students take calculus, right? A, S, T, C. Now, if the sine function, let's say for instance, in the second quadrant, if the sine function is positive and cosecant also, that implies that everything else, tangent, cotangent, cosine, secant, those are all negative, right? So everything is positive in quadrant 1, but in quadrant 2, only the sine function and the cosecant function are positive. Quadrant 3 is going to follow the same suit, with tangent being positive and then cosine and sine being negative. And also its counterpart, cotangent, is positive. Quadrant 4 is the C quadrant, and that means that cosine is positive. Everything else is negative except for secant, which is the pair of the reciprocal of cosine. So let's take a look at this into practice. Now let's go ahead and solve this problem here, which says to first determine the quadrant for theta, then find x, y, and r, which are dimensions of a right triangle, and finally find the value of all 6 trig ratios for theta. Right, we can use the inverse trig function to actually find the value of theta, but we actually don't need to, so I'm not going to go that route. The first thing here that we are told is secant is equal to 16 over 7. Since secant and cosine are reciprocals of one another, this means that the cosine of theta is equal to 7 over 16. So these two pieces of information, now the cosine is equal to 7 over 16 and the sine is less than 0, tells us quite a bit that we can do, that we can decide to use in order to find the quadrant in which this angle is located. Remember, all students take calculus mentions that everything in the first quadrant is positive. Since the sine function here is defined as negative, that means quadrant 1 is not possible. And by the same token, quadrant 2 is not possible, again, because the sine function is positive there, and this one has a negative value for the sine function. So now we're looking at either quadrant 4 or we're looking at quadrant 3 as our answer. Based on the other piece, which is here, the cosine function is positive. Not just the fact that it's equal to 7 over 16, but by the fact that it is positive, that tells us that it cannot be in quadrant 3 because in that quadrant the cosine function is negative. So that puts us at a quadrant 4 scenario, right? Theta is in quadrant 4. So let's draw ourselves a fourth quadrant angle, shall we? Let's use a new set of XY axis, and let's let's zoom in on the fourth quadrant because the other piece doesn't really matter. So we have an initial side over here. We have a angle that swings around, and this angle lies in quadrant number 4, just like so. If we draw a perpendicular line based on where the reference angle is located, which again is underneath the x-axis, we can draw a perpendicular line to the x-axis to create a right triangle. Let's see, so let's make this line in green, just so our triangle looks a little bit different. Okay. So what do we know about this right triangle here, right? We see, hopefully you can see a right triangle located right there. Let's go back to the information we're given. So cosine of theta through the secant of theta being equal to 16 over 7, we're told here that the adjacent value is equal to 7, and we're told that the hypotenuse value is equal to 16. That's because cosine by SOHCAHTOA is equal to adjacent over hypotenuse. So that means that the hypotenuse can be called 16 over here, the hypotenuse, and the adjacent up here can be called 7. The Pythagorean theorem, so actually by coordinate geometry, this 7 is also called the adjacent, but it's also labeled with the x variable. The hypotenuse, which is 16 in this case, can be labeled with the r variable. And then we have the opposite side in red, which is also going to be called the y variable. Right? And we can find this value by use of the Pythagorean theorem. 7 squared plus y squared is equal to 16 squared. That's going to make 49 plus y squared equals 256. Subtract 49 from both sides, and that means that y squared is equal to 207. Take the square root of both sides of this equation. That means y is equal to positive or negative radical 207, and we are only using the positive side because this is the side of a triangle. So radical 207. So x is equal to 7, y is equal to radical 207, r is equal to 16, which answers this portion of the question up here. So now let's find the 6 remaining trig ratios for theta. Redrawing our triangle, we can redraw it in the same fashion that we were given. This is the hypotenuse. Our angle is here. The hypotenuse was 16. Adjacent was here. That's going to equal 7. And opposite is here. That's going to equal the square root of 207. The sine of theta, the cosine of theta, and the tangent of theta are our 3 main trig functions. We already know that the cosine of theta is equal to 7 over 16, right? That's what we were told. But now using opposite over hypotenuse, we can find the sine of theta to be radical 207 over 16. We can find the tangent of theta to be opposite 207 radical over adjacent, which is 7. But remember, based on ASTC, based on all students take calculus, since we are in the 4th quadrant, that means the sine function is negative. That means the tangent function is also negative. Now, if we are to find the rest of the 3 trig functions, the cosecant of theta is going to be the reciprocal of the sine function, so negative 16 over radical 207, which will need to be rationalized into proper form. That's going to be negative 16 radical 207 over 207. The secant of theta is going to equal 16 over 7, and this information was given to us already, so technically there's no need to write that down. Tangent of theta is going to have a counterpart called cotangent, and we can flip this value, the reciprocal, to get 7 over, that's a negative 7, over the square root of 207. Rationalizing this brings us to an answer of negative 7 radical 207 over 207. I hope that helps. Please ask questions during class if you have them.